Suppose we want to add a node to a list and we want to keep this list in ascending order. There are three very easy possibilities, and they are if our list is initially empty, or if the new node goes in front of the head, or if the new node goes after tail. The harder situation is if you want to put this node in the middle here. So logically, algorithmically, it's easier if you deal with those three possibilities first. And the reason for that is that you know then that it's not going to go before head, and you know it's not going to go after tail. You know that absolutely it's going to go in the middle somewhere. So let's look at our options. Here we have temp. This is the new node that we've created. So the first issue is look at whether our list is empty. And to see if it's empty, we look at head. If head equals null, we have an empty list, and therefore temp is going to be the sole member of this list right now. So if head is null, all we do is make head equal temp. So now head points to wherever temp is pointing, and this is our new list. But maybe we had a list, it was not empty. Head is not null. So now I want to know if the item in temp is less than the item in head. Since items are objects, I have to cast them. And because in this example they're integers, I can use the less than or greater than symbol. For anything else, I would have to use compare to. So look to see temp's item. If temp's item is less than head's item, that means temp has to go in front of head. So to do that, and I have to be careful the order I do these things in, I make temp's next point to head, and then I make head point to temp. So now I have head pointing to temp, which you recall was less than this, what used to be the first member of this list. Now I'm ready to look at the next situation, the next possibility, which is if temp's item is greater than tail's item. I moved my temp node from the left to the right just so that it was closer. So if temp's item is greater than tail's item, it's going to go on the end, in which case I have to make tail's next point to temp, and then I will make tail point to temp and no longer point to this node. So I put it in at the end, and I've moved tail to point to the last node in the list. Now, if it's none of these situations, if our list is not empty, if temp's item is not less than head, if it's not greater than tail, obviously it goes somewhere in the middle. So now I have to look at this fourth possibility. I start out with current pointing to head, so current equals head. And I want to stop current when it is at the node which will immediately be in front of temp. So I have to go along my list, obviously in a loop, saying current equals current.next until I find a node where the next one, in fact current.next item, is bigger than temp. So when I know that current's next item is bigger than temp, I know that I have to put this temp in between current and the next item. We'll look at the code for this later, but what happens is I put this so that we have this situation here. Just be a little more careful with where these arrows come from. So current's next points to temp, and temp's next points to what was current's.next. And so I have them in order. Now we should look at code. In this program, I have used 3, probably 4, there's a temp down here, node pointers. Some students get concerned about using too many. In linked lists, there's no such thing as too many of these things, and you can always throw some more in and then just delete them if you don't need them and don't use them. That's fine, but so don't be scared of or afraid of having too many node pointers. These are pointers to nodes. This is my input, and the reason that I put it in an array is just because I didn't want to get the input from the keyboard and then have to look in the output box to see if in fact I had got every integer in my list, and that I had the correct ones in the list. So I just threw it into an array. You do not have to have it in an array. So these are our 1, 2, 3, 4, 5 numbers, and if you can see, this is our output and it is in order. I was careful about these numbers. The second integer will have to go in front of head. The third one is then going to go in between -3 and 67. The fourth one is going to go right on the end, and the last one is going to go somewhere in the middle. So I've got initial case, in front of head, in the middle, after tail, and in the middle. So that should test all possibilities here. So the first thing to do is to check if head is null. So, well, the first thing maybe is to make a node. So I take the node, I make a node with the integer in the first item of the array, so the 67. And if head is null, if our list is empty, then head is temp and tail is temp, or tail is also head. So what would happen here is that we would get a single node pointed to by temp, by head, and by tail. Else. So now I'm going to check if I need to add something in front of head. So I get head's item and I have to cast it. I have to cast it to an int. Even though up here on line 20 it clearly says that head item is an int, and I knew that head was a node and I had put an int in it, but when you add something to a node, it goes in, it's kind of recast as an object, and so I have to cast it back as an int. So I have to cast it here to be an int. And now I can look at it and say, okay, if the thing that I want to put in is less than head item, then I wrote it here for you. If the thing you want to put in, if the object you want to put in is less than heads item, then temp.next is head, temp.next temp.next is head, and head is temp, so head is going to come here. So now I've got head pointing to temp, which had an item which was less than heads item. Here's the next one. If the item I want to put in is bigger than the item in tail, then tail.next is temp, so tail.next is no longer null, but points to temp, and tail equals temp, so tail equals temp. Sometimes with a piece of code like this, tail equals temp, students get confused. Does tail now point to temp, or does temp now point to tail? Always go back to first principles. X equals 3. What gets changed? Is the 3 changed, or is the X changed? You know this. It's the X that gets changed. The thing on the left of the assignment is the thing that gets changed. Okay, so tail gets changed. It gets changed to the address of temp. So tail now points to temp. And then the harder one is if it's neither less than head or bigger than tail, somewhere in the middle. So start out with current pointing to head, go into a while loop, looking for if the number I'm trying to add, if the thing I'm trying to add is bigger than current's next item, then move current on. I want to stop when the thing I'm trying to add is less than, and you can say less than or equal to current's next item. So if I grab that piece of code, now I start out with current pointing to head. And while the thing I'm trying to add is bigger than current's next item, move along. It could be that it isn't bigger than this right away. It could be that the integer in head was 5. The one in head's next is 7. And the one in temp is 6. So it is not bigger than the next one, and I have to put it in between head and head's next. But wherever I stop current is pointing to the node whose item is less than temp, but whose next item is bigger than temp. And this is an entire while loop. So I didn't put the braces in, but just watch that. This is an entire loop. So when I'm out of this loop, then I say, okay, temps next is currents next. So temps next points to currents next. That's this node here. So this is going to point here. And currents next points to temp. So currents next points to temp. No longer points there, and I've hooked them up. Now some students say, does it matter which order these two statements go in? Yes, it matters very much. Let's go back to where we were. And let's reverse the order of these two statements here. So the first thing we do is current.next equals temp. So current.next, which is here, equals temp. So it points to temp and not there. And now temps next equals currents next. Temps next, I would like it to point here, this one here. But that is not currents next. Currents next is temp itself. So we would have temp pointing to itself, and we never ever able to get to the rest of our list. So yes, it matters a lot. Once I alter currents next, I cannot get to this node. So I definitely have to do it in the right order, and that is to say temps next is currents next. Currents next has a value, it is this node. Set temps next equal to that, and then currents next. Now I can break the link. So you have to be real careful the order that you do these things in. And the only things remaining in here are to print the list when everything is done, when the list is completely done. And I always ask you to do the print list in your homeworks when you have built your list, because you need to know at the end that you actually have a list built. You can't just grab a node, make a node, print out the contents of a node, and then do something else. You have no way of knowing then that your list is correctly built. So let's do that. And there we go.